Hi guys, it's me, Mr. Bertoch, your incredibly handsome science teacher. And in this video, we're going to be talking about weight and mass. It is going to be really hard for me to do this video without breaking into a song about mass and weight because there is a really awesome video that somebody did on YouTube a long time ago, like 10, 11, 12 years ago. That is about mass and weight. And I play it every time I teach this in a classroom. And so mass and weight are in my head as a song, but I will do my best to refrain from singing about mass and weight. So our goal by the end of this video is to understand what is mass, what is weight, and how they are similar, how they are related, but how they are not the same thing. Mass and weight are two different things, but they are closely related to each other, and that can be confusing. Okay, and that's okay that it's confusing. If you are a little bit confuserated, I will do my best to help clarify the difference between them. So let's start with mass. What is mass? Well, mass is part of the word massive, right? Or massive has the word mass in it. What does massive mean? If something is more massive, what is it? Like, for example, a hippopotamus is more massive than my dog, Clara. Well, what does that mean? What does it mean for the hippo to be more massive? It means that it has more mass. It has more matter. It has more, in other words, atoms in it. That's all it means. That's what mass means. Mass is a measurement, but I prefer the word measurement. I prefer putting a S. You know, there's silent letters in words. Well, I think there should be invisible letters. And anyway, I'm getting off track. Measurement of the amount of atoms in an object. So a hippopotamus has more atoms in it than a dog does, and that's really all it comes down to. Well, how am I going to measure the amount of atoms in an object? That's pretty impossible because literally even tiny objects have trillions and trillions of atoms. And I don't have eternity to sit and count how many atoms. I mean, counting to a trillion, several trillion would take a long, long, long time. Many millions of years. Okay. And I don't have that long today. I'm pretty busy. So I can't count how many atoms are in my dog Clara or in a hippopotamus. It's just not possible. So we have to cheat. We have to cheat and use weight. And this is where it gets confusing. But first, let's talk about what weight is. What is weight? Weight is something that makes me very sad every morning when I step on the scale and I see how fat I am. Fortunately, I'm less fat, though, than I was a few months ago. Because COVID, I got all puffed up and I've lost some weight recently. But anyway, you don't care about that. But what is weight? Why, when I step on the bathroom scale, why does it say that I am such a fatty? Or what is causing it to read out the weight that it says that I am? Okay. It's gravity pulling me down on the scale, right? And the more massive I am, the more matter I have, the more atoms I have, the more I'm going to weigh. because the more gravity is going to be able to pull on me and tug me down. So you see how this is connecting to mass? Mass is the amount of atoms I have, but weight is also related to the amount of atoms I have, because the more atoms I have, the more I weigh, the harder I'm being pulled down onto that scale. Okay. So why are they then not exactly the same thing? Well, here's the deal. Here is the dealio. If I go to, let's say, the moon and I step on a scale, do I weigh the same as I weigh on the earth? The answer is no. I weigh less on the moon not because my matter has changed. I still have the same number of atoms, but what's changed is the strength of the gravity, because the moon has less gravity than the earth does. So weight is both a measurement of the number of atoms I have and also the strength of gravity where I am. So I'm going to weigh more if I have more matter, but I'm also going to weigh more if the gravity is stronger. Matter doesn't change. Mass rather doesn't change. Okay. I have the same number of atoms whether I'm on Jupiter or Mars or anywhere that I go. My mass stays the same, but my weight changes. So both of them are related to the amount of atoms I have, but weight has that additional rule. Weight is also impacted, in addition to the amount of matter I have, it's also impacted by the strength of gravity. Okay. Now, when we are on Earth, well, when we're anywhere really in the universe, the way that we measure mass, because I can't count the atoms. I can't sit there forever and count how many atoms do I have and report that and write that ridiculously long number out. So we don't measure mass by number of atoms. That's what it is. But instead, we measure it by Earth weight. So when we talk about mass, we will say that my dog, I don't even have the slightest clue how many kilograms she weighs, to be honest. But we'll say that an object weighs 100 kilograms or 100 grams. Grams is the unit of measurement for mass. Well, if something on Earth has, if its mass is 100 grams, its weight is also 100 grams, because we're using Earth weight to represent the mass. But if I go to the moon and I take that object that has a mass of 100 grams to the moon, it still has a mass of 100 grams, but the weight has changed. Okay, now maybe the weight is only 20 grams on the moon, but the mass is still 100 grams because we use Earth weight for mass as a measurement of mass. Now, I know that that's a little bit confusing, so watch this video about 3 more times and give yourself a chance to let it all sink in. Take a deep breath. It's okay that it's a little bit confusing, and it'll come into focus for you. So again, the mass is a measurement of how many atoms an object has. The weight is a measurement of how many atoms an object has and the strength of gravity in that area. And we measure both using grams because we can't count the number of atoms, the mass of an object. And so we cheat and we just weigh it, but we use Earth weight for mass. So on Earth, the mass and the weight are going to be the same number. But if I go to the moon or somewhere else, the mass is going to stay at the Earth weight, but the weight will be different because gravity will have changed. Okay. And notice, by the way, I'm very proud of myself. I did not sing Mass and weight, they are not the same, not the same. Mass and weight. Oh, wait, now I did. Darn it, I ruined the whole video. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.